And welcome to Aughton Math. In this edition of Aughton Math, we're going to talk about two ways of solving linear systems algebraically. All right, so let's talk about the first method, substitution. And we used that in the prior lesson, 3.1. We were talking about solving linear systems graphically. And we included that as part of our discussion. So let's review it again. So substitution is method number one. We have two different equations, and again, systems of equations. They have two variables, and the variables are going to be the same, and they're equal to some constant or zero. So the first step is to solve one equation for one variable. So we take 2x plus 5y is equal to negative 5, and x plus 3y is equal to 3. And then we solve for one variable in terms of another. So let's take 2x plus 5y is equal to negative 5, and we're going to solve that equation for y in terms of x. So what we do is we subtract 5y from both sides. I'm sorry, we subtract, so we're going to solve for y in terms of x. We're going to subtract 2x from both sides, and we get y is equal to, let me write this down, 5y, excuse me, is going to be equal to negative 2x minus 5. And then we divide both sides by 5, and we get y is equal to negative 2/5 x minus 1. And you can see that this is the equation that we came up with here. Y is equal to negative 2/5 x minus 1. So again, we rewrote in terms of one variable and solved for that one variable in terms of another. So I have y is equal to negative 2/5 x minus 1. Then we use this equation and we substitute the value of y into the second equation, which is x plus 3y. So we substitute minus 2/5 x minus 1 in for y, and then we solve for x in that particular expression. So we have y is equal to negative 2/5 x minus 1, and we have x plus 3y is equal to 3. So let's rewrite that as our x plus 3 times negative 2/5 x minus 1 is going to be equal to 3. So I can rewrite that as x plus negative 6/5 x minus 3 is equal to 3. Now what I'm going to do is I'm going to add 3 to both sides, and I'm going to combine the like terms for the x variable. And so I get negative 1/5 x, because negative 6/5 x plus 5/5 x is equal to negative 1/5 x, is equal to 6. Then I'm going to multiply by negative 5, and I get x is equal to negative 30. All right. Once I have the value of x is equal to negative 30, I can substitute the value of negative 30 in to either equation and solve for y. So now I have, if I take the second equation, x plus 3y is equal to 3, I can say negative 30 plus 3y is equal to 3. So I'm going to add 30 to both sides. I have 3y is equal to 33. And now finally I have y is equal to 11. So my ordered pair solution is going to be negative 30 and 11. All right, so that's the substitution method. Let's talk about, again, this is just finishing off what I did before. So I solved for the remaining variable by substituting the value from step number 2 into the first equation. So x is equal to negative 30. I plug in, or I should say substitute in for x, and x plus 3y is equal to 3. I have negative 30 plus 3y is equal to 3. 3y is equal to 33, and y is equal to 11. So it's the same process I went through in this example. So the second method, we're going to move on. Second method is elimination. And in elimination, what we're trying to do is we're trying to align the coefficients for one of the terms and then subtract or add those terms to eliminate that particular variable and then solve for the second variable. All right, so what we're going to do is we're going to multiply one or both equations by a constant to obtain a coefficient that differs only in sign for one variable. So in this case, what I want to do is I want to multiply my first equation by negative 2. When I multiply the first equation by negative 2, it ends up as being negative 6x plus 14y is equal to negative 20. So I multiply every term by negative 2. I get negative 6x plus 14y is equal to negative 20. And then I keep this particular equation the same, because what I want to do is I want to eliminate the x variable by adding these two equations together. So I line them up this way, and I would add them just like I add any multi-digit number, but now I'm using variables and constants for two different variables. So I have 6x minus 8y is equal to 8. And so I add these two together. Moving on to the next page, I add these two together, and I get 0x, right, plus 6y is equal to negative 12. Now I just solve for y. So 6y is equal to negative 12. I divide both sides by 6, and I get y is equal to negative 2. Now once I have the value for y as negative 2, I can use that value to substitute back in to either equation and solve for x. So let's take the, it looks like the first equation, 3x minus 7y, and I'm going to substitute, or let's say plug in, substitute in 2 for y, and I get 3x minus 7 times negative 2 Okay, so let's review the two different methods. The first is going to be substitution. That's where I solve for one variable in terms of another, and I use substitution. I substitute that value that I get for that one variable back into the second equation and solve for that variable, and then use that value that I get for that one variable to solve for the second variable. In elimination, I'm going to align one variable with a coefficient that is the same value but the opposite sign. I'm going to add the two equations together to eliminate one variable and then solve for the second variable. Once I solve for the second variable, I can go back and solve for the first variable, similar to how I did, or what I did for substitution method. All right, that's it for Otten Math and solving linear systems algebraically. Come back and join us for some practice problems on YouTube. We got a couple to do for you. Shouldn't be too long.